All right, thanks for sticking around with me. And here goes my actual official intro, more in the shape of a timeline. So I'm going to start this conversation with a timeline, end it with a timeline of what's to come. Here's the timeline of me. Pre-Hiro, I was building blockchain and digital asset solutions more on an enterprise blockchain level. I got into blockchain. My foray into blockchain has been more from an engineering curiosity. So trying to figure out how blockchains work, what are the various consensus algorithms, et cetera, et cetera. Roughly 4 months ago, I joined Hiro in their mission to build developer tools, improve developer experience for the decentralized web via stacks. And that's where my life started getting better. My life changed for the better until one wintry morning, just like any other day, minding my own business, and everything went apeshit. And if you don't know the reference, please come and find me later, and I'll explain it in more detail. From that time, I think it was a lot of congestion happening. There was a huge NFT mint. And if you don't own a megapont, you probably should. Join in on the fun. This is no way a marketing pitch. But yeah, so right after that event, sometime in Jan, Aaron from Hiro opened up a GitHub conversation about Hyperchains and how we think as Hiro could improve the scalability and throughput of stacks in general. So from then, the conversation took into shape. Now we started building Hyperchains, a layer 2 solution. And we are towards end of March, April now. We are at milestone 1, and we'll cover more about that later. All right, so even before we talk about what Hyperchains are, I think something that we want to understand is the fact that blockchains do not scale. You probably heard about this a gazillion times by now. And why is that? So many applications that are usually built on blockchains require high throughput. A lot of transactions happen. You want speed. You want low latency use cases that are built. Maybe we can scale one application that is built on a blockchain to the way that we want it to perform. But imagine a plethora of such applications being built. Scaling all of them for high throughput and low latency is going to be a challenge. And that brings us to the blockchain trilemma, as we call it, like an engineering problem that many have tried to solve before us, after us. The trilemma: decentralization, scalability, security. You can have one of them, two of them, not all of them, right? For Bitcoin, we are optimizing for decentralization and security inherently. So that leaves out the scalability aspect of it. And stacks in nature also does the same thing. So we are decentralized. We are highly secure. By that, we are limited in our scalability options. And they're really opposing requirements to say you cannot have both of them. That is because the runtime and bandwidth limits of a blockchain are fixed. So as traffic hits you, the blockchain cannot increase its limits and therefore cannot handle new traffic. And decentralization, stacks, as we know, prioritizes decentralization. And it comes with two integral traits. That is open membership and user verifiability. So open membership is the fact that anyone, anywhere, anytime can run a stacks node. They can mine. There's no entry-level requirements in the sense that there's no minimum staking that you have to do to join as a stacks member. And then it also comes with user verifiability. So these two properties combine and they place a limit in the size and frequency of the blocks that stacks in general can generate. So the solution for that is Hyperchains, where we're trading decentralization to an extent for performance. And how do we do that? So rather than losing the decentralization axioms for the entire network, we're augmenting it with a second layer on top, calling Hyperchains, so that users have the flexibility to decide between the two. If you have a high throughput application, high throughput requirements, low latency, you join a Hyperchain. You join the Hyperchain bandwagon. And if you want really the true decentralization, you stick with the main network. So These are really ideal for certain use cases, NFT marketplaces that we just talked about, decentralized exchanges, DEXs, and some collectible games. So how does Hyperchains achieve this? High throughput for transactions, low latency for transactions. So for high throughput, we solve this by allowing bigger blocks in our transactions, so more transactions can go through the Hyperchain. For low latency, it's also very similar. We allow this by allowing bigger blocks in the Hyperchain. But in addition to this, we also allow microblocks within the Hyperchains. So microblocks do exist in Hyperchains, and we allow for delivery of high confidence confirmations more instantly by doing this. So let's peel the layers a little more further, talk about what exactly layer 2 is, what exactly the network of a Hyperchain is, and what exactly stacks is. So starting with layer 2. Layer 2 really means that the block mining at the Hyperchain level depends on the stacks network. So you cannot really fork a Hyperchain without forking a stacks chain. So they're very, very tightly coupled there. Network. Hyperchains are just like blockchains themselves. They're a network. They have blocks. They have transactions. They have their own consensus rules. This means that Hyperchain blocks could support many more transactions than a typical stacks chain would, because it's operating at a different level. And also, Hyperchains are designed to transact on stacks assets. It could be FTs, NFTs, and we'll cover more of that later. Users can move their assets to and from the stacks chain however they want to via smart contracts, and they trust the consensus rules that are set at the Hyperchain level. And that's a very interesting point to note, to say that the consensus rules for Hyperchains can vary. We are allowing a design where you could have a very federated model in a Hyperchain, and you could also have a very decentralized consensus model in another Hyperchain, and anything in between. And we'll dig deeper a little bit. So here's a closer look at the Hyperchain architecture itself. As you can see, on the left side is the Hyperchain contract that usually stays on the stacks chain, that lists all the Hyperchain miners that that particular Hyperchain would have. And on the right, you'll see one such Hyperchain and all the miners there. So how do users interact with both these scenarios? Imagine you want to move an asset, say an NFT, to a Hyperchain. You call the Hyperchain contract on the stacks network. So the assets can be deposited, withdrawal requests. Let's say you're depositing an asset. So the miners on the Hyperchain are listening to the Hyperchain contract on the stacks chain. So when the deposit happens, that asset is basically moved, or it's actually transferred to the Hyperchain, because the Hyperchain is listening to all the blocks that are being produced by the miners. So you go to the Hyperchain now. You can do the transactions as you would typically on a stacks chain. You move your assets around, you deposit, you withdraw within the Hyperchain. And once you want to get out of the Hyperchain, for example, you minted an NFT on the Hyperchain, you did all your transactions there, you want the NFT to be moved to your stacks chain, you send a withdrawal request to the smart contract, the Hyperchain smart contract. And for that asset to move to the stacks, there's a consensus mechanism where the miners in the Hyperchain miners that you see on the right need to approve that withdrawal. And once that approval is done, the asset is moved back to the stacks. So basically what you're doing is moving a bunch of traffic to the Hyperchain layer, doing your transactions like minting, very high throughput transactions, and moving it back to the main chain. Very straightforward, right? Another thing to note is that the participation for this Hyperchains is optional. You don't have to be part of a Hyperchain at all, unless you want to be. Trust me, you want to be. But when you are part of that Hyperchain, you will trust the consensus, you will trust the you will put your trust on the consensus model within that hyperchain, the miners that offer you. And that trust, again, varies, like I said, from a fully trusted model where miners are responsible for issuing the hyperchain blocks. Users validate, but withdrawals are issued arbitrarily by a hyperchain miner. So trust can be federated via Byzantine fault-tolerant protocols there. They're very key for a fully federated model. And then federation, you require the majority of the miners to approve your withdrawals, like a typical BFT algorithm. So that's a fully trusted model. On the far end of the spectrum, which I think is more of an ideal hyperchains situation or a model that we would want to, but we have a long runway there. It's a fully trustless model, very similar to what we have on stacks. However, the miners are responsible, again, for issuing the hyperchain blocks. Users validate. Withdrawals, they're issuable only if they correspond to a current state. Here, we need a new form of consensus mechanisms or cryptographic techniques because it's a fully trustless model. You cannot just rely on a subset of the miners to say, you can withdraw or this is a valid transaction. And this brings in really innovative algorithms that we are exploring, like zero-knowledge proofs, probabilistic checkable proofs. If you're into math and crypto, this should really tickle your brain cells. It's a very interesting space. So that'll be an ideal state, a futuristic vision that we are also working towards, and more to come on that later. So let's take a closer look at the version 1 of Hyperchains, which is what us at Hiro are working. So for the version 1, it's going to be a BFT-based, federated trust-based Hyperchain model, ideal for, say, an NFT marketplace. So when you set up a Hyperchain, each Hyperchain will designate a set of miners. It could be individual miners or a collation of miners or a federated set of miners. A Hyperchain node receives blocks signed by this set of miners specifically and validates those Hyperchain blocks. Again, for withdrawals and deposits to and from the Hyperchains is also possible. They're completely trusted. The assets are stored in a Hyperchain and entirely controlled by the miners within that Hyperchain. And because it's a high level of trust, it is really ideal that we split that trust amongst a coalition of miners rather than just a single miner to each their own. So withdrawals can then be processed by the approval of this coalition. So like I was saying, NFT launch, let's presume now Megapont or whoever you are wants to move to a Hyperchain and you want to launch a use case with us. You'll have an NFT contract there living on the Hyperchain, a Hyperchain contract on the stacks, corresponding NFT contract on the stacks blockchain. All the withdrawals will go to that specific Hyperchain contract. The mints occur in the Hyperchain. And then at the withdrawal time, the Hyperchain contract invokes the mint command on the NFT contract that you see there on the stacks chain. So that brings us to the timeline where we are at right now at Hiro. The goal, we divided the journey to the first version MVP of Hyperchains into 4 milestones. We are at milestone 1. For milestone 0, our goal was to really have an end-to-end testable build, which we achieved towards beginning of March. And then goal of the milestone 1 was to really enable that active listening to stacks commitments as they're happening, so you can snoop in to what's happening on the Hyperchain at the moment. So we are very, very close, probably a couple of days away from that milestone. So if you are curious and if you're interested in knowing more, reach out to us. There's nothing actively that you can do at the moment where you can withdraw or deposit, but you can just watch the activity as it's happening in Hyperchain. Still exciting though, right? Like me watching somebody play a video game rather than actually playing the video game. So the next goal is to have milestone 2 towards the end of May, where you'll have block validation, multiple signatures happening, There'll also be a multi-party commitment proposal and signing protocol. I would actually flip M2 and M3 a little bit because we're actively looking at the Hyperchains contract right now, which is the deposit and withdrawal contracts we are actively working at. Once that is done, we will be able to simulate an NFT use case on Hyperchain. So if you are interested in test driving with us, obviously let us know if you want to play around with that. So end of June, ideally we would be able to launch a case study where we want to learn from this experience of our MVP1, see what the gotchas are, see if that fits the use cases that we're looking to build. And beyond MVP1, really the goal is to get this into mainnet probably end of this year or early next year. Again, TBD, don't quote me on that for the timelines. There's a lot of bells and whistles. We have to tap the loose ends around security audits and whatnot. So keep your eyes peeled on that. Follow us on our GitHub conversations. Join us on Discord. Reach out to Aaron or I or the rest of the team at Hiro. And we have, you can follow us on our GitHub. It's called Stacks Hyperchains, the repository. All the activity, as usual, is public. There's a lot of interesting conversations happening. You can see the milestones, the progress there. And again, it's not just hype, it's Hyperchains, my cheesy tagline. So that's all about Hyperchains, what we're doing at Hiro. If you have any questions, happy to take them. Yeah.
So about the roll-ups, I don't know if those were ZK
Yeah.
roll-ups or optimistic roll-ups, but even me as a developer, I'm still trying to wrap my head around this. Could you kind of explain in layman's terms how these developments would compare to similar developments that have been happening on Ethereum with some of their layer 2s like Polygon or some of the proposed scaling mechanisms that they might implement on Ethereum involving different types of roll-ups?
Yeah. So mathematically, they'll be very similar, right? Ultimately, zero knowledge proof is zero knowledge proof. How do I prove you are who you are without owning the information that you own? That's the like ELI5 for zero knowledge proof. So it'll be very similar. We're exploring some algorithms. We're not at a place where we have zeroed in on saying this is the algorithm we want to follow. But in my past life, I've worked on zero knowledge proofs and kind of led some of the initiatives for Hyperledger Besu. Yeah. Yes and no, because the algorithms itself, it is a different ecosystem altogether. Like we were talking about clarity, the language that we're using is going to be completely different. But mathematically, the proof itself will be very similar. Yeah. Okay. I don't know if that answers your question, though. Yeah. Yeah.
So from the user perspective, if I'm trying to do an NFT event, would I have to go to Yeah, sorry. So from the user perspective, if I'm doing an NFT mint for maybe a Megapont, and do I have to go to my wallet and then switch to the Hyperchain network?
Yeah.
Okay.
Yeah. It'll be very straightforward and more on to come on the details of the user experience itself, but it'll be simply like switching your network ID from mainnet to testnet. You will be switching your network ID from mainnet to the Hyperchain ID. Do your things there, mint, transfer, withdraw, and then switch back to the mainnet. Again, easier said than done. The user experience itself, the look and feel, how the wallet will behave, how the Explorer will behave, we're working on that. So keep your eyes peeled on updates sometime around Q3.
Okay, thank you.
Hi, and thank you for the presentation. So I'm kind of new to Hyperchains here, but I am familiar with the concept of application-specific blockchains. Is this a singular layer 2 solution? And what happens if the network becomes congested? Is there an ability to open up a third, fourth, fifth Hyperchain? Yeah,
that's a really, really good question. It's slightly different from app chains specifically, and I know that the foundation is exploring that. I think Marvin and Jude can speak about that a little bit more. But yeah, the idea is that you would have multiple hyperchains as an option, and each could have their own consensus mechanisms, like I said. Like few could be very federated, few could be very decentralized. Obviously, we're not there yet in the decentralized spectrum, but yeah, we allow for multiple hyperchains to happen. Again, If you want to participate in the test drive, we'll be happy to include you all. Let's figure out with the first hyperchain, and then we can scale from there. Yeah.
I was just wondering, so with version 1, you said it is federated for mining. How does mining look? Is it hardware requirement, or are you spending an asset?
Yeah, so it'll be very similar to what we have on the Stacks main chain at the moment. No additional or different mining requirements or hardware requirements that are needed there. The only difference would be that the arrival of the conclusion of the consensus would be more BFT based than what it is on the Stacks at the moment, which is proof of transfer. So it is more like if you're looking for a permission blockchain, if you're familiar with that, and enterprise blockchain solutions, they use more BFT. They lean more towards BFT. Like Hyperledger Bezu, for example, they use Quorum, for example, they use BFT. So that'll be the consensus mechanism there.
Okay, great.
All right. All right, thanks for having me and tuning in. Cheers.